I got invited to give a Keynote tutorial, which is a new style that I haven't done previously at ICRA, which happened. And they basically asked him, hey, Peter, you've done lots of educational resources, you've written books, you've done many toolboxes, can you please come and present your toolboxes? And they told him you can bring a friend along. And Peter picked me as his friend, so we split the presentation. It was a 90-minute slot into two. So the first 45 minutes, Peter presented on his spatial math and robotics toolboxes and machine vision toolboxes, etc. And then he handed over to me for the second half, presenting on how we get from research code to running systems. That's how I phrased the presentation. So what I really want you to take away from today's talk is that when I did my PhD a while back, a lot of my time was spent in trying to get someone else's papers to reproduce, right? We all want to come up with the tables in our papers, and despite us knowing in advance that we're going to have the bold numbers, we have to show the other methods as well, which, like we want to get comparison results of. And that was always super hard, especially in robotics, because robotics, you have like many things coming together, right? Like we have our perception, action, loop, so you have various components all coming together. They all have different dependencies, and getting them to run on the machine is always super hard, right? And what we're going to show you today is how to make this a little bit easier. So that's number one, basically getting your own code and other people's code to run easier. And then the other thing is that, I'm someone who's super passionate about making everything open source, open data. And in the past, it's always been a two-stage process. First, you've done things in your hacky way and get it to run on your own machine. And then you were happy and you got some results and put stuff together. And then you submitted your paper, and then eventually, hopefully, it got accepted somewhere. And then I was like, oh shit, now we need to make it, nice and polished so other people can use it. And understandably, many people are like, oh, I don't want to go through this trouble of the second step because that's going to take me a lot of time and effort, and I want to work on my next project as opposed to, polishing some code that I worked on 6+ months ago. And in the talk today, I'll maybe motivate how I think that those two steps have now come together and are unified into a single step, and how we can basically make sure from the very first day that our code is somewhat polished despite us still being able to prototype and hack our way around things. Okay, so that was a long preamble and basically going through many of the things that I put on the slide. And as you can see, the slides are a bit geeky as well, so they run in a terminal. And I'll tell you in a minute how you can set up this terminal and the slides and yourself as well. But just repeating here, my bucket list is that I want to be able to run ROS, I want to be able to use CUDA, I want to be able to use PyTorch, all the things that are currently being used. And I don't want to tell people, hey, Lewis, please, on your MacBook, install your Linux Ubuntu 2204 virtual machine. And then we would basically be taking the time, and the talk would be over, and we'd have our virtual machine installed and done nothing else. Okay, so I want this to be able to run on Linux, Mac, Windows, etc., and multiple programming languages as well. Right, so people are using C++, Python, Rust, whatever you want to use, and with the tools that I'm introducing, you can use any of those. So we want to make systems runnable on multiple machines, repeatable, and portable as well. Okay, so who in the room has lost some time for if you couldn't install a dependency easily, or if you couldn't download a data set that was listed on a GitHub repository, or it just worked on your machine and never again? Right, okay, so that's hopefully the majority of the room. Great. Okay, so the thesis is, right, the tooling, like the software tools, they now become part of how research is shared, reused, and extended. And it should be a single workflow, what I told you earlier. So this is what currently most research repositories look like, right? You clone some weird repository, and then people tell you, please install Ubuntu 20 or 4 because I tested it on there, and then run some sudo apt install and pip installs of some random packages which may or may not work. And then please also compile like your custom OpenCV or your custom this and that, and then download the model manually from the Google Drive or something, which or some Chinese thing that you can't access. And then they tested it on their machine, and I was like, I want to make, now my code is open source, right? And that's how most research repositories look like, and then it's basically up to you. They're like, all right, you deal with it, you do the rest. This is not what we like. So the question is, what if the README instead had one command to do all of those things for you in a repeatable way? And this is what we want to get to. Okay, so if you want to follow along, then what you do is to run these commands that I can't highlight because otherwise you won't be able to read it anymore. But starting down here, you git clone and a head. Okay, can everyone read this or want me to make it bigger? Yeah? So you git clone github.com/petercorke, then it's called ICRA26 modern software tools.git. Git clone this repository in a folder. I'll give you a minute to do that. Still see people typing, so I'll wait a minute.
I don't have Pixi.
You don't have Pixi? That's okay. You'll do it in a minute. It's not good. That's all good. So I'll actually go on here. It's a good point. People don't have Pixi. I'm not comprehended. That's fine. No, that's impossible. If you don't have Pixi, then you go on, you open the URL that you just typed in manually, and then there's some tools which tell you how you install Pixi. It's a single line. Either you copy this one if you're on Linux or Mac OS, or you copy this one if you are on Windows. That's on the repository that we just typed in. github.com/petercorke/ICRA2026-modern-software-tools.
Choices was not expected here.
That is one. Say it again.
Choices was not expected here. It might be an old version of Pixi.
That you have a old Pixi. There you go. Everyone okay? No?
Yeah, done.
Are you done? Okay. Done. Michael, you okay? You got the slowest in the room?
Yeah, I'm on Windows, but I'm okay.
Cool. Okay. Then we go into. Has everyone installed Pixi as well? Yeah. Cool. Then can you change into this directory that you just cloned? So cd ICRA and then tab to autocomplete. And then you should be able to Pixi run presentation. And then you should be greeted with something that looks like this. You've got an old Pixi.
Pixi, yes, Pixi sells.
Living at the edge. Okay, people all right? Okay, so how you navigate around is pretty self-explanatory. You just use your arrows to navigate around in the presentation. And if you want to execute a code cell that will be coming up soon, you press Control and E to run the code. Okay? No? Even on the Mac. Yes. Yeah? Obviously, I should tell you, with all the security things going on at QET, you should only be running those presentations if you trust the author. So I'm trusting that you trust me to a certain degree. All right? Okay. Now, the tool that we will be using to make all of those things happen and run like a single command readme is called Pixi. And with Pixi, who's been using Conda in the past? People are familiar with Conda. So Pixi is an extension of Conda, which allows you to add a project workflow as well. So Conda was simply like, you were able to install dependencies and packages. Pixi goes a step further, and you can actually create a workflow. And what I mean with a workflow, I'll show you in a minute. So we're going from like the old way of a README script, of some shell script, of oral tradition, or like ask the previous student, right? Like when I did my PhD, it was Miguel. If you didn't know what to run, you asked Miguel. There's like people like that in every lab, right? And now instead what we have is just a pixi.toml file that we will create now during this talk, and an associated log file. And this log file basically tells you exactly which packages were installed at the given time, so others can exactly reproduce it later on. And then you just say, Pixi run something, just like you did with Pixi run presentation. That's your task. And as you could tell, it installed your dependencies and it was running some things that magically just worked. And if you want to, that's like really nice for continuous integration, etc. as well. I should have mentioned, if you do have questions throughout, just ask me, right? Just hack it. It's okay. Okay, how do we start a project? We run Pixi init. So this is the first time that we press Control-E. And then it tells you, okay, I created this pixi.toml file. And we can expect the toml file, what it looks like later on. And this is, like super easy. And then we can add some dependencies. So here we are adding PyTorch, because that's what I assume most people would be installing like as a priori thing. And that's, as you can see as well, it's fairly quick. And again, people, if something doesn't work, just raise your hand and I'll come and help out. But so far, so easy. And that's so far the same that you would have done with Conda. It would have been Conda install, now you'd use Pixi add. One thing that did change compared to Conda and all the other things is that Pixi is like super fast. So if you're installing a new environment, if you're adding packages, when I first started using Conda 10 plus years ago, everything took forever, right? And now with Pixi, even if you have like a very complicated environment, the solving only takes like 5 seconds, solving and installing. So it's a lot faster than what Conda used to offer back in the days. Okay, and then we can obviously, do whatever we want to do. So in this case, just like a standard PyTorch script that we can now run. I'm not going to go into detail what's going on there because it doesn't matter, but just to show you that now we installed PyTorch, so even if you didn't have PyTorch installed on your laptop previously, you should now be able to run the script. And I'll show you later how we can reproduce the script on a different machine as well. All right, another question. Who has like a command that you regularly type on your laptop that you memorize, but that you didn't want to memorize in the first place? It's like, okay, all right. So now we're getting to this workflow bit, all right? So what you can create are what Pixi calls tasks. So a task is simply a command that you want to run. So in this case, we want to run this training script that I just created for you. And some of the special bits in tasks is that you can add dependencies. So in this training script, let's just pretend that we are using a data set. And the data set can be downloaded in a different task, which is called download mlist. Okay? So now you can build up hierarchies of tasks where you basically say, okay, I have a training script, but that depends on the model weight download, and the model weight download might depend on something else, or data set download. And then we can do this. And I never know why I'll make it a bit smaller. Okay, something changes in the resolution. And what it also enables you to do, if you run this task now, the first time around, it's actually going to download mlist, okay? So downloading MNIST will take a while. Imagine there's like a super large data set that'll take 10 minutes or something. And previously what you would have done is you were in Python, you're like, oh, if this file already exists, then don't download it again. What you can do in Pixi is for each of those dependencies, you can define the input and output files. So you can say, my download MNIST task outputs some training files, and you say what their names are. And then the next time you run the task, run it again, and it's not showing. But that was like instant, because it didn't actually download MNIST again, because we had specified the file name of the outputs was already downloaded once, so we're not downloading it again. Does that make sense so far? Yeah? Cool. Nice. Yes, Luis.
Will I be able to download data sets from Hugging Face as well?
Yes. Yep. So you basically, Pixi doesn't add any new commands. It just runs commands. So from Hugging Face, you would use the Hugging Face CLI or API, or use wget or whatever you use to download them. So you still need to implement how the downloading is happening. But now instead of like you having to remember the URL and put it in the README, it's now like all within the TOML file that you share with other people. Yeah, cool. Okay, and obviously, like nowadays, we're mixing lots of stuff, right? Like we're mixing ROS, OpenCV, lots of pip packages, and so on and so forth. And previously, if you wanted to mix conda packages with pip PyPy packages, you always ran into issues because you were overwriting some stuff from your conda packages and it was like non-deterministic, just a pain. With Pixi, all you do is, instead of saying Pixi add and then the conda package name, you say Pixi add -- PyPy and then the PyPy package name, and it resolves them in a deterministic order. So you don't need to worry about different ecosystems anymore, which is really nice. And so there's no boundary anymore. So here, like here's your conda dependencies and then your PyPy dependencies. And that's needed because a lot of the packages are available on conda, but not all of them. So now it's like a nicer way to use some other packages. Okay. Now, who's using ROS in the lab? Yeah, not too many. Who's installed a virtual machine or something to get ROS? Yeah. Yep. All right, we want to avoid this. And if you've known me for a couple of years, I presented on RoboStack previously. So this is like now the RoboStack part. So ROS, for those of you who don't know, it is a robot operating system. So it's like a nice system to communicate across different nodes. There's lots and lots of ROS packages for, again, everything you can think of, SLAM, perception, object detection, Maruko marker detection, and so on and so forth. And what you can do with RoboStack is to run ROS on Linux, Mac OS, or Windows, combined with those conda packages that I just mentioned. So how do we do this now? And again, it's just an example. It could be other packages. So sometimes people might want to have like a private channel where they add some stuff with their own packages. And this is now like two commands where one command, you basically say, okay, I want to add a new channel because it's not on the default conda channel. And then the other command is adding the actual ROS package of interest. So here it's ROS rolling desktop. And now those two commands have installed ROS. If we compare that with install ROS2, then you go on the documentation website and you say, I want to, like install it in Ubuntu, and you're being presented with a table of contents of roughly 20 things you need to do. And then with each of them, you go through, you do this, you apt install that, like all of this is basically tucked away in those two commands that we just ran. Okay, people still okay? Following along? Nice. Great, and then just to show you that it's not, actually I'm not lying to you, you can go on the next slide. And now like the Turtle Sim, which is a standard super simple simulator that you can play with, just pops up. And then you can actually command it as well. So that's it, right? That was 2, you were running the node, and then you created a ROS message on a topic. And the total sim is doing its thing, just like you would have learned in the first ROS tutorial that you've done. Okay, so we can all have all of those things now in one environment, which is really, really powerful. And obviously, what I haven't shown you so far is I've showed you like you can install all of those other people's work, right? But we are doing research, so we want to do our own work, right? Our own code. Oh no, sorry, I skipped too far. One slide too far. The other cool thing with RoboStack is that you can now install multiple ROS distributions on a single machine as well, super easily, side by side. So you don't need to have a single, like one machine for your ROS Humble and the next machine for your ROS Kilted. If you want to try a new ROS distribution, you just add the new channel, install the same packages, and you can now specify from which environment you want to run your command from. So here we use the Humble environment or the rolling environment, and that is all that's required to change the environments. And we still support ROS1 Noetic as well. So if you still have a robot that runs on Noetic, you can run it too. Now we are going into building our own stuff, okay? So let's say we want to create a new ROS package, and we just use the standard command, ROS2 package create. In this case, it's like a C++ package, and we call it the ICRA ROS package, okay? Because it's typical, topical. And then we can create this, and we can play around with it in whichever way we want. So here, now is your manual coding part, which is not covered in the presentation, but just imagine you're doing your own thing. And now, instead of running colcon build, you can just run Pixi install. And what Pixi install creates is actually a conda package. So now, this example package here has just created a .conda package that I could share with all of you. So I could upload it to a channel and tell you, here's my new research code, give it a go, and it would simply be like Pixi install Tobias ICRA ROS package, and you would have it on your machine. So it's like a super easy, streamlined way of distributing packages as well. And then, does it work? Of course, like it's cut off, but it would just say hello world, basically. Yeah, so it's quick. Okay. Any questions up to this point? Scott?
Yeah, the ROS example where you had the different versions of ROS, is it installing that like multiple separate times? And so then does that consume like a huge amount of space?
It's a really good question. So Scarlett's question for those online who haven't heard, Scarlett's asking if you have multiple ROS distributions, does it take up a lot of space? And that's the same with multiple PyTorch versions, let's say, right? So if those ROS distributions rely on the same dependencies, then it will only use the same amount, like it will only create it once and not multiply the files that are needed, at least on Linux and macOS. So it's relying on the file system features of your operating system. And it's the same for PyTorch. So if you have multiple PyTorch environments, all using the same version of PyTorch, that are only downloaded once and use up that space once. Now, if you install PyTorch 2.10 in the one environment and 2.11 in the next and 2.12 in the next, that's going to take up 3 times the amount of space. So if you want to be careful, basically always reuse the same version of PyTorch, and then you're good to go. And there's a Pixi feature that I will not talk about today, where you can basically have like a shared set of dependencies and then an additional separate list of additional things that you want to add on top. And in that case, the shared list of dependencies is always using the same packages again and again to avoid this explosion of space. It's still better than Docker, for example, where in a Docker image you have like, there are gigabytes and gigabytes every single time you create an image. That's not the case here. Yeah, Mason?
Is there an easy way to print out full list of stored dependencies
In C, we have to go to file storage and find them.
No, you just go in the repository and say Pixi list, if you can type, and that's listing all the packages that are installed. Yeah. Cool.
Do the Pixi maintainers have to maintain anything on top of the ROS stuff?
Cool. So let me give you a bit of background on how those packages work. Okay, most of the non-ROS packages, they live on a thing called conda-forge. Conda-forge is a community-driven, basically, repository of conda packages. So anyone who wants to contribute a new package can just create a pull request on the conda-forge repository and add a new package. So anyone in the room, like it doesn't need any special permissions, you don't need to request anything. Basically add a new package, and I can show you how to do that in a separate talk. And then the package is just there. That's like the conda-forge, the non-ROS dependencies. For the ROS dependencies, they live in the RoboStack repositories. And there, if you want to add a new package, it's as simple as adding, let me give you an example. So we go into ROS Humble, and then people want to add a new package, and they just add, like literally, I don't know, that's a bad example, but I basically add one line of code in a YAML file to build that new package, and then it's me who is approving it. So.
And then when, like, I presume when the ROS maintainers release a patch, it flows through to...
Exactly, yes. So every now and then, periodically, we rebuild the whole RoboStack packages. That happens every couple of months. And then we get the new versions from ROS. Yeah.
My other question is about CUDA.
Yeah.
So you're maintaining the CUDA library versions, but you don't maintain the system level drivers?
Yeah, so you need to have a CUDA driver, that's correct. But all of the other libraries are being packaged on conda-forge. Yeah. So if you have any questions, it's super simple nowadays. All you need to say is add a dependency called PyTorch-GPU, and it's installing the GPU version of PyTorch with all the CUDA stuff. And then if you're building your own packages, you might need some more development tools of CUDA, and I can show you which they are. There's like a long wish list. Yeah, cool. Any more questions? Okay.
Are Pixi and RoboStack well supported for edge devices too, Jetson?
Yes, they are. So Jetson runs on an architecture called AArch64, and we provide packages for them. Not all of them, but I want to say 95% of the robotics packages. And most recently, even the CUDA ones. So Ted, who's not here, has got the DGX Spark. Is it the Spark? I think they call it, the NVIDIA. You can now run the conda packages with CUDA enabled on the Spark. Yeah. Cool. Okay. Now, you can build not only ROS packages as easily as I've just shown, but it could be any CMake package, any Python package, any Rust package, or even a Git repository. So you can add a Git repository as a dependency, and it will build it for you as long as it's like one of the supported things, which is most of the things that we work on. Okay. So far, we were running everything on one machine, right? Like everything was running on my MacBook. But I promised you that we would have cross-platform support. I'm going to show you, hopefully, how to do it in a second. So it's not the, what is it? The things that I want is we want to use the same repository. We don't want to have like multiple repositories. The same log file, the same commands. So it's Pixi run presentation regardless of whether you're on Windows, Mac, or Linux. But different machines and different operating systems. And one of the things I haven't mentioned is that we don't need any root access, okay? You don't need sudo, you can install it on the teaching machines, whether they want it or not, because you don't need sudo to install. So what you need to do is you explicitly need to tell basically which other platforms do I want to add. And in this case, I say I want to add the Linux platform and Windows platform. And what it does in the background is basically looking up which packages work on these platforms and adding them there. And here it tells you, okay, I added those two platforms. And to get back to Goku's question, you would add Linux-arch64 if you were to run it on a JSON file or something. And then, did I skip something? This will not work for you. It'll only work for me. Well, maybe it's going to work for me. It didn't work in ICRA. Doesn't know. Okay. Okay, I'm not going to... give me one second. Should work. No. No. Third time lucky. Maybe. So what it does now, it's copying over the stuff to Zeus, which is one of our local server machines, and starting the internet client, which the ref team doesn't automatically add for security reasons. So it's okay. And then it should run the same PyTorch script, yes, which it does, on the machine. And now it actually works. So it added PyTorch GPU, and it's now downloading the MNIST dataset and then running the training script. Okay? And nothing has changed. And the cool thing is here, obviously CUDA wasn't available on my MacBook, but now it installed CUDA on this machine as well. All right? So that's as easy as it can be when you want to run things on HPC, for example, right? Like previously it was like a big mess in copying things over and making sure they work over there. Now hopefully it's as easy as cloning the repository on HPC and then run Pixi, run whatever your task is. Okay, now some advertisement for Alex's vSlam lab, and that's just one of the examples. So whatever your research field is, I pitched it at the beginning of the presentation, but one of the things that we commonly want to do is we want to be able to benchmark our system against other systems on many different data sets. And for Visual SLAM, it's like SLAM has been around for a long time, so there's a lot of methods and a lot of data sets that people are interested in. And if you read a typical SLAM paper, they will evaluate their method against a small set of baseline methods on a small set of baseline data sets. What vSlam Lab does is extending this to basically a lot of methods, so dozens and dozens of data sets. And what it enables you to do is then check, do those methods really work as well as they are advertised in the paper, even on those other data sets that it didn't test on? Or did they maybe strategically hold out on those data sets because it doesn't work as well? And previously it would be like a long, like installing ROS, building OpenCV, like all of those things, downloading the data sets, configure CUDA on a particular Ubuntu machine, then pray that it works. And what we can do with Pixi, or with vSlam Lab, I should say, credits to Alex, is that we can run OrbSlam, in this case, on my Mac, or thanks to Margot, on your Windows machine, or on Linux, on this particular data set. And this is just one example. We could now change the data set name to some other data set, or the method name to some other method, and it would run basically the system there. And you can now evaluate those systems. So obviously not everyone in the lab does SLAM, but that's just like an inspiration of what is possible, which previously would have been very hardly feasible just because of the complexity in getting those systems up and running. Okay, I'm running out of time, but Pixi obviously has like all the bold things, all the green ticks that other methods don't have. So compared to Conda, we have those workspace management, and it's faster. Don't use pip. UV only works for Python, same for poetry. So the claim is it does all the things that the other things don't. So it's not just one feature, it's like the combination for robotics. Docker. Why not Docker? I've always hated Docker, so for me it didn't need a lot of convincing. And the reason being that those things, like those Docker files, are never understood, right? There's like so much magic that happens, and then you have this Docker run command. It's like 6 lines with some magic volume mounts and magic storage copy over whatever. So it's great if you want to have like exact reproducibility, but like we want native graphical interfaces, low friction hardware access, host networking, super easy composing of ROS and machine learning. We want it fast, right? Like creating a Docker image is super slow, and cross-platform. And this is what Pixi basically gives you. Okay? All right, so far everything has been great, right? Like 21 slides in, and I told you about all the cool things. Now I want to be transparent about the not so cool things or the hard things that remain hard with Pixi. Okay? Some of the robotics software is still like Linux first, right? So if you use a Linux kernel API in your project, it's not going to magically work on Windows, right? It still needs to be compiled and built for Windows. And basically, what happens is that you do a lot of the things once and properly instead of doing them repeatedly. So when you create those packages, you do it once, you build it, and it works for you once. And if you make it available to the community, other people don't need to struggle. So you see a lot of pull requests of me creating like a Pixi.toml file for random projects that me or one of my students want to use. And then I can reuse that pull request over and over again and have done the work once, right? So the work still needs to be done, but now you do it once and then everyone else is happy. And obviously like Pixi is one layer. There's many other tool chains which still have their place. I'm not saying that they go away. And those log files that Pixi produces, they capture the complexity, but they don't make complex systems simple, right? Like the interoperation across different software packages is still complex. So you still have setup cost, but you can now inspect things, share things, and rerun things. And many times, like you will need some patches, modifications to the source code to get them to compile with Pixi. Got 3 minutes left. Some teasers. I showed you this previously, but you can now run ROS in the browser. So you don't even need to install Pixi there. You can run things in cross-platform continuous integration on GitHub. So there's a setup Pixi task, and then you basically run your things. So you make sure that if you don't want to change platforms over and over again, you can just use one of the GitHub workflows and runners. And you can super easily create those packages. So there's like a command there that you can run, spatula build, and then generate recipes, which basically does most of the work for you if you want to package a new package. And something else that's cool, which should show up, if you play a lot with, training your machine learning models, you have a lot of the weight files lying around, right? And they rely on a particular version of your code. And then over time, there's like a discrepancy of your weight files and the code that you're using. What you can do with Pixi is you can package basically anything. And what you can say is, here's my weight file. Let me put it in a conda package. And let me constrain the version of my custom research code to exactly this commit on my Git repository. And then you can basically pull in and say, okay, for this weight file, I need this exact commit of the repository, and then run everything easily. So that's a nice way of sharing rates around. You can upload those rates to the Anaconda prefix channels as well. Okay, last minute. So you now have your environments. You can create some tasks to create dependencies and forget about remembering magic one-line commands. Local code now hopefully is like shared across, and you can share it with other people. And then you can make the software part of your paper contribution as well. Yeah, and that's me finishing right on time. Thank you. Still going to be around for questions, but I can understand if you want to head off for lunch as well.
How do you stop the Oxfam demo? I hit Control C and it's excellent presentation, and I want to hit X on the demo, which is reopened.
Can you close the OpenCV window? No?
No, and this X on the
Well, you wait 3 minutes till the data center. Yeah. Oh, Margaret, do you have a set of Windows machine you copy?
It's quite to mine. I also
Is it Windows or Linux? Yeah. Linux? Oh. Yeah. Sorry. I can only tell you on Mac you press the X. Gary, question?
Not really a question, I just want just a comment that I think everyone knows, I guess everyone knows presentation can be tricky and conference like ICRA, and I think the live demos of something like this is like, if you ever tried this, you probably know how difficult that is. If you tried it multiple times, you really know how hard it is. So I think really want to shout out Toby for doing this here, but doing this as an original new format, ICRA, along with Peter on top of that, which is pressure. I think that's quite amazing. So yeah, really big shout out to Toby and Robotics.
Any other questions? No, I think. Oh yeah.
Can you go like Qt apps? Does that work nicely on Windows, or does it like
yes? Yep.
like all the GUI ROS stuff generally is fairly
Arvis and everything.
Yeah.
It does require some work. Sure, it's now. Again, it's like a one-off, right? Like you put in the effort once. Yeah. Cool. Thank you, everyone. So much.
Thanks, Toby.